Welcome students. Welcome to the video lectures of software engineering. So today we are going to talk about architectural design. Okay, creating architectural design. So under this, first topic is software architecture. What is software architecture? The architecture of a system is a comprehensive, which means a detailed one, comprehensive framework that describe its form and structure, its components, and how they fit together. And the architecture serves as a blueprint for the system, ensuring that it meets both functional and non-functional requirements such as performance, scalability, and maintainability. So that is what software architecture is. So basically, the software architecture is a high-level structure of a software system where it is defining you the components of the system and their interactions and the overall design principles which will guide us to the software development. That is what is being specified here. Okay, so just you can just think of this software architecture. Just let me write. You can think just this as uh, so software architecture as a skeleton. Okay, as a skeleton of the system. Clear? Where the individual components will represent the organs, architecture, ties, uh, that everything, to the function as a whole. So for example, let us take an online banking system. So the architecture of that might consist of the components such as front-end application, which is used by the user interface, and a back-end server where the business logic is processed, and a database where customer information and transaction details are stored. Clear? So that is about software architecture. Then there are a set of principles for data specification. So we'll see what are those. So when I say the set of principles of data specification, okay. So first one is apply systematic analysis to data, that is like functions and behavior. Then identify data structures and their operations. Next one is define data content and associated operations. Then delay low-level data decisions. Then restrict access to data representations. Sixth one is build a library of reusable data structures. Next, last one is use a language that supports abstract data types, that is ADTs. So let us try to discuss about one in brief. So first one is to apply systematic analysis to data. Okay, like functions and behavior. Just as we analyze the functions and behavior, we should also analyze the data. So what are the things that fall under analyzing the data? So like we have to create some data flow diagrams, or we need to identify, okay, we need to identify some data objects, okay, or you can consider, sometimes the alternative data structures that exist, and evaluating how the data also affects the software design, all these things. Okay, all these things fall under your first principle. So second is identifying data structures and their operations, which means for for, for every data structure, so we need to clearly identify what the operations that will be performed on it, the operations that will be performed on it. Okay, and then third one is define data content and associated operations. Okay, so what it is trying to explain us is, so there should be a clear mechanism, to define the content. Okay, to define the content when I say attributes, okay, of each data object and whatever the operations that apply to it. Okay, so by using some UML diagrams, we can achieve this, okay, by clearly showing what attributes exist and what operations that are to be performed, all these things. Then fourth one is delay low level data. Okay, delay low level data decisions, which means we should not rush, okay, to decide the data format or to decide the implementation details, all these things. We should not rush in deciding these things very early, where the data organization should be outlined in the requirement analysis, and it should be refined during the data design and fully detailed during component level design. Then that is what this point specifies. Okay, delay low level data decisions. The fifth is restrict access to data representation, which means only the necessary module should know how a data structure is implemented. Okay, then next is um, build a library of reusable data structures. That is, we have to develop a class library of the frequently used data structures and what operations are associated with them. Okay, so by doing this, what happens? Reusable. The term reusable means the reusability will be promoted, and of course, consequently, the time. Okay, we can save the time by doing this, right? As we are not reinventing the wheel. Then the last one, seventh one, use a language that supports abstract data types, which means we have to choose a programming language that lets you define and use, complex data types very easily. Clear? So these are all the set of principles for data specification. So then we talk about the data design. So what is data design? So data design is nothing but, you can see here, the data design focuses on how the data will be structured, stored, and accessed within the system. And it ensures that the system can effectively manage and process the data, both in terms of performance and integrity. Clear? So, which means, primarily it is focusing on how the data is structured, especially for our software design. Okay, and as we have were talking about a online banking system in the software architecture example, where we are bothered about the front end, back end, and the database, like where the customer information is stored and the transaction details are stored and how they are retrieved and all those things. Okay, and here let us take another example like a social media application. Okay, so before that will finish this. Data design include data modeling and data flow. So data modeling is what? It is the creation of data models. Data flow is nothing but the movement of data between components. Let me write here. So data modeling is the creation of data model to define the structure of data, whereas data flow is the movement of data between components and systems. That is data flow. So yeah, we were talking about an example of social media application where the data design might involve, defining the user profile in the sense what the name of the user, age, and the location of that particular user, and the posts in the sense the content, the timestamp, or the likes, whatever they made, and some comments in it. Comments also will have like the author or the text or the timestamp of that particular comment and all those things. Okay, the flow of the data might involve user actions, like posting a comment, okay, which will trigger an update in the database and notification to the relevant user and all those things. This is how the data modeling, data flow under the data design works. So then we have architectural style and patterns. So under architectural style and pattern, first one we are talking about is a data-centered architecture. So a data center architecture is a data store. You can see it is mentioned here in this example, the data store. Okay, repository or blackboard is mentioned. So a data store resides at the center of this particular diagram. You can observe that where the database is residing at the center of this particular architecture, and it is being accessed frequently by the other components, like updating or add or to delete or modify the data within the store. Clear. So here you can see the data store, which is associated with the client softwares, which is being accessed frequently by all those connectivities. Then we have data flow architecture as the next thing. So data flow architecture is the architecture is applied when input data are to be transformed through a series of computational components into output data. So a pipe and a filter structure has set of components called filters, which are connected by pipes, which that transmits the data from one component to the next. So in the diagram, it is very evident where each filter works independently and produces data output of a specified form. This is how the data flow architecture works. Okay. Then next we have main program or subprogram architecture. So when we talk about call and return architecture, like a client and server kind of thing, so which enables a software designer to achieve a program structure that is relatively easy to modify and scale. That is call and return architecture, we say. So in that, this main program or subprogram architecture is nothing but it's a where the classic program structure will decompose the function into a control hierarchy, where the main program, which is on the top of the diagram, you can see where the main program is invoked and number of program components, which in turn may invoke still other components. So main program, controller subprogram, then application subprogram, and it is also further classified to application subprogram. Clear. So that is what the invocation of main program, which invokes number of program components, again which in turn may invoke still other components. So then we have object-oriented architecture, where the components of a system will encapsulate the data and other operations that must be applied to manipulate the data communication and coordination between components. So it's accomplished via message passing. Okay. So that is object-oriented architecture. Then we have layered architecture. So the layered architecture, there will be a number of sub-layers or different layers that are defined. You can see core layer, utility layer, application layer, user interface layer. So which are defined, and each accomplishing the operations that progressively become closer to the machine instruction set. Okay, where at the outer layer, the component services under user interface operations, and at the inner layers, the components perform operating system interfacing. So intermediate layers will provide utility services and application software functions. And once requirement engineering uncovers the characteristics and constraints of the system to be built, the architectural style or combination of styles that best fits can be chosen. Clear? So this is how the layered architecture will work. Okay. Right. Thank you, students.